Thank you so much. So welcome everybody on the day one of discussion four, where we have two special segments to this session. One is, of course, related to the development of application, as we mentioned last in the last discussion, and the other section is about data analysis, which will be led by David Martinez from Mexico. So I don't whether Without wasting further time, I would like to welcome the first three facilitators who will be talking to us about app development, launching, and designing. Anna Hanhausen from Mexico, Prachi Shevgaonkar from India, and Wen Tian from China. So over to you, Anna, and I'll share my screen.
Thank you so much. Drishya, you will be sharing the presentation then? Okay, awesome. So my participation in this session of the conclave will be divided into two sections. The first one will focus on how we can go from an idea to a product, right? Because sometimes what we do is that we get to an idea, we're ready to, we think we're ready to launch it and everything, but there's a whole process that we need to do research and market analysis and different things to make sure that we reach the most appropriate solution. So I divided this explanation into three parts. Trisha, if you could go to the next slide, please. So first we have the solution. Getting to the idea, right? So first, what we need to do is spot a problem, then we find innovative solutions, and then we choose the most feasible solution. In the solution section, what we do is first we have to create a brief, do some research, and think of our users and create different user journeys. And finally, once we execute, what we will have to think about is the architecture of the app or the technology product that you want to create, the product development, and the testing and launching. So, Risha, if you could go to the next one, please. So when we talk about an idea, first, like I was saying, we need to spot the problem, right? So what we need to think about is a problem that's happening in our region, our city, our country, or even in our small town, right? It doesn't have to be, it can be from a very local scale to a very global scale, depending on what you want to solve. And something else we need to think about is how this problem is currently being solved and what is missing. Because sometimes there are already small solutions going on, but they're not the optimal solution. So the problem is not really progressing. After we spot a problem, we need to find the most innovative ways to solve these problems. So, as I said before, we need to think of what the current solutions are missing. Then we need to think about what additional solutions could be implemented. We need to brainstorm about what could be done. And finally, we can think about how technology can help us achieve these solutions. When we have this different list of the different ways we can take to reach a solution, we need to find the most feasible and impactful one. To do this, we need to think of the scope of each solution and if this solution creates systemic change. So if this solution will actually solve the problem from its roots. If we go to the next slide, we will talk about thinking about the solution, right? So once we have this solution, this idea that we want to execute, we have to create a brief. So what we do in the brief is describe the problem and the context of this problem. We describe the product that we want to create and the requirements. So this is our first approach to putting in paper what we want to do. Then we have to start doing some research. We have to think about the market context and the market research. For example, socioeconomic or different developmental facts about where we're trying to solve the problem are really helpful. We need to think about case studies, look at other solutions that would be, in technical terms, the competition of the solution we would try to create, and think about how this new solution that we're trying to create will solve some of the problems that the competition is not solving. And finally, we have to create different user journeys. In these user journeys, we have to think about who is our objective user. We have to create different archetypes. So let's say, for example, Drishya could be an archetype, Ivan could be a different archetype, and we have to create flows of how these users will move throughout the app. Once we create these flows, we will find different pain points of how they currently should solve a problem and how these pain points are addressed in our new solution that we're proposing. So this is how we can go in deeper into the solution. And now if we go to the execution section, once we if you go out there we go once we get to the execution. Okay, so with this previous steps we already have an idea, right? And our idea is taking a very specific form. Now we know exactly what we want it to look like, and once we know that, we need to put that in paper, right? So we have to start with the architecture. The architecture is basically the bones of the app you will start creating, and the first thing you need to do are the wireframes, which is basically putting the idea from your mind, how you think the app will look like, into paper, and thinking about how the user journeys will look like in this idea that you've drafted. Once we have these wireframes, which are hand drawn or in the computer, we have to create a sitemap and a state machine, which is basically a mind map that shows how the user will interact within the app, right? So for example, we say, oh, the user logs in and then he goes to this page and then he goes to this page, right? So we need to create the different flows of the user. And we also need to create the state machine, where we put more details of where he will receive a notification, how he will exit different pages, and we need to keep all this in mind, right? Once we have the architecture, we go into product development. For this, we need to look into design. We have to decide if we will be doing the design, or if we will think about talking to someone else who is an expert in design to go from wireframes to actual screens that we will add to our application. And something that's very important is decide what language you will be using for programming, and if you will be programming it yourself or if you will be hiring development. For example, in my case, we decided to hire a team of developers who are the ones who are helping us with the actual product programmation. And finally, we have the section of testing and launching. Something I really recommend is testing with small groups, but having these small groups being very varied, right? Not only having, for example, 10 of my friends who all lived a similar life in its general terms, but actually going and finding different users and really trying to reach all of the objective users that we planted before, right? That we were thinking about. Once we address all the comments that they made, we get to different beta versions. We can start launching different beta versions that we will have to keep updating and keep making better. And finally, we need to prepare for the launch event. So in this launch event, I will talk a little bit more in detail further on, but basically what we want to do is put our product out there so people can start using it. Thank you so much. This I will come back towards the end of the session to talk about the launch of the event more in detail. And I think now it's Wen's turn.
Thank you. It's very inspiring because, like, even as an app developer, app designer myself, I don't really think about like creating a new app, but I only design like those functions, how this function is going to work and how it's going to serve people. Dasher, would you mind click the link, because I have find an amazing YouTube for 5 minutes that we can use to learn how actually to start with how an app is, like how does an app work. So I think it's a very good starting point for us to understand how to design an app. Would you mind to click the link here?
Where is the link?
It's on like how does an app work?
Okay,
there is
got
a
it.
link behind. Yeah.
This is Angela from the AppBury.
Can you hear? Can you hear something? No?
We can hear something,
I'll
but
reshare my
I'm not sure if it's clear.
Okay.
To digging in and building apps, the first thing I want to talk about is how exactly does an app work? Because we all have it in our phones, we use it to do really important things like banking and contacting friends, but there's actually very few people who knows just exactly how an app actually works. So let's start off by getting an overview of that. Now, the first thing we have to realize is that smartphones are actually no different from just any other computer. And an app is just code that tell that mini computer what it should do. So let's say we have an app that just has a single button on it that says click me. When the user taps on the screen of that phone, then the sensors in the phone register that tap and sends a message to the operating system, which in the case of an iPhone would be iOS. Now, the operating system then looks at the data that it gets from the sensor, including things such as how much pressure was applied onto the phone, at which location on the phone screen did it register that pressure, and a whole bunch of different things and a whole lot of numbers. But the operating system takes all of those numbers and makes sense of it. And once it does, then it'll know that this particular button on the screen of this particular app was tapped at this time point. And then it'll send a message to the app in question that, hey, this button of yours got tapped. What should it do? And so the code that you write for your app should specify, in this situation, when the button called Click Me gets tapped, this is what it should do. It should change what's shown on screen, and it should do this and that and that. So essentially, as an app developer, you're planning out all of the scenarios and what should happen in each case. So it's almost a bit like emergency planning. If the building is on fire, what should happen? Well, we should probably evacuate the staff, and we should probably shut all the doors to prevent the fire from spreading. Well, it's exactly the same for apps. What should happen when a user taps on this particular button? Well, we should change the screen background to red, we should show them some other pieces of information, and then we'll wait to see what's next. And then there's a plan for how to respond to the next event. So there's essentially only 3 components to every single mobile app. There are the user interface elements that you see on screen. So that can be things such as buttons or images or toggles and sliders. And when we first build our app, we're going to set up the screen. So we're going to drag on some buttons, place it in a location that we think makes sense, and then add images or add other interface elements to the screen. Now, when those elements get interacted with by the user, say somebody taps on the button, then we've got the second component of the app that comes into play, which is the code. And this code is the plan. If this button called Click Me gets tapped on, then what's the next thing that should happen? Well, it's step 1, do this, step 2, do that. But if the user, say, used the slider, then in our code, there'll be a section that plans for what should happen when the user uses the slider. And finally, most of the apps, especially if it gets more complex, will have data that's stored in the app. So for example, let's say we have a contact management app, right, where we have all the phone numbers of all of your friends and colleagues. Well, on the screen, when the user taps on a button that says, show me Bob's phone number, then that will send a message to our code, and we check through all of those lines of code to see how we should respond when the user taps on that button. And then the code will go into the data and fetch the relevant piece of data. So in this case, that's of course Bob's phone number. And then it's going to send it back onto the screen and display it on the screen so that the user now sees the telephone number of Bob. Now, previously I mentioned that a smartphone is just like a smaller computer, but there's still a few crucial differences. The first difference is that a laptop or a desktop computer is usually plugged into the wall, but is usually wireless. We usually keep it in our pocket and it's not always charging. It's also a lot smaller, so the battery gets depleted much faster compared to a laptop. Now, a phone also has less processing power. So if you try to play something that's really intensive on your phone, say the latest Far Cry, or if you try to run Photoshop on your phone, then it's not going to be able to do it because it has less memory and less processing power than your computer. So because the phone has limited resources on all of these fronts, then in order for a user to actually have a good time using their iPhone, then we have to manage those resources very frugally. So for example, you can't just make an app that drains the user's power in 5 minutes, or make an app that's so demanding on processing power that it's so slow and barely chugs along on the phone. So in all smartphones, there's always a manager, somebody to manage all of those resources. And that is, of course, the operating system. So it's iOS in our case that we need to worry about. And this manager is a little bit like the factory boss. It tells our app, hey, you're about to come on screen now, get ready. The user wants to see something from you, don't let me down. Or it might say, hey, you're draining the battery way too much, I'm gonna have to shut you down. Or hey, you, little app, the user's getting a phone call right now. I'm going to have to switch you off. Make sure you save their data before you go home. And this is what I think about every time I see my apps shuddering and shaking in fear. So previously, we looked at the 3 components that make up any app, namely the screen, the code, and the data. Well, we actually have to zoom out a little bit and see the bigger picture, which includes the role of the operating system. So when we think back to that plan that we're writing when we're coding up the apps, then that plan has to take into account all of the events that happen, not just when a button inside the app is tapped or when the user shakes the phone when our app is open, but also things such as when the operating system tells us that the user is getting a phone call. So our app is going to be switched into the background. So we have to also plan ahead for those situations. Well, if the user is getting a phone call, but they were midway through filling out a long form inside our app, we don't want them to come back after the call and realize all of that data has been lost. So we have to plan on how we save that data when a user gets a call, for example. So all in all, when we build an app, we're essentially writing a very long and very extensive plan to plan for what should happen under lots of possible scenarios. And when the app is launched on the phone, it looks to this plan to see what it should do. So in the course, we're going to be digging into every single aspect that we spoke about in this lesson.
I think this is
This is a little bit of a teaser
video.
of what's yet to come and what you're going to be learning about, so that by the end of the course, you'll understand exactly how the app works and build any app that you dream of.
Yes, I think this is the end of the videos. Thank you. I hope this video can help you understand how an app is working, and like try to think, like consider yourself as an app developer and like start to constructing the app. Like, Drishya, would you mind to share the PowerPoint? Yes. Next slide, please. Okay. Sorry, I have heard a lot. Echoes. Sorry, Drishya, any problem? Let me.
No.
Or you want me to continue?
Can you tell me from which slide number I need to start?
I think it's number 8.
Is this okay?
Number 8.
Number 8. Okay.
Sorry, number 7.
Okay.
So in this page, I have like my own presentation, on how, like what kind of app that we are developing.
Maybe Drishya, if you mute yourself, remove the echo.
Yes, there were a lot of echoes, Drishya. I think. Do you think it's better now?
There's still the echo.
It's still echoing.
Yeah.
Still echoing.
Yeah.
Maybe if we stop sharing screen and then put it again.
Yeah, I think if we start, like when we share screen, don't click on share with sound. I think that could be the problem.
I already did that. Is it better now?
I don't hear echo now.
Yeah.
So is it okay now?
Yeah.
Great. Thank you. So I have this like small classification, like unofficial classification of myself on how to divide different levels of app, basically. So the first one is going to be a bit easier than the restful kind of app. So the first one is like the app doesn't need backend support. So for example, app that is a dictionary, a calculator, so you only need to add those logic in the app. So it's most of the logic is inside the app coding system. So so basically there is no information transaction between the app and the server. And then the next two type of app that which most of the current app that you are using that require a backend support, which include a lot of information transaction between your phone and the server. For example, let's say WhatsApp that you send a message to a friend, and actually you are sending a message to the server, and server need a record of the data that you have sent a message, said hello to your friend, and then they will find your friend and find your friend's account and send a message to your friend's phone. So there is a lot of interaction. And the third type is that was mentioned in the YouTube video, that an app that may requires those efficiency consideration, not only in the app itself, but also in the backend support. Let's say if you are running a professional or app that are very popular, that you have to consider that if 1 million of people are using your app in the same time, in the exact same second, how your server are gonna survive this kind of situation. So you're gonna face like very successful product designing if you can reach the fourth step. So next slide, please. Drishya, would you mind to go to? Yes, please. Thank you. So and this slide is try to describe what kind of person or need to be included in app designing team. So I have marked two roles that are like fundamentally important in design an app. The first one is project manager or user interface designer or app designer, whatever you call it. Is basically the designer of the app. They have to design what app is for, and like how it's going to work, what's the structure, and how the app is going to jump from one page to another. So it's basically the designer of the app. And also another fundamental part is the developer. Developer actually have divided into different kind of developer. So the Android, iOS, or web developer are the most crucial. So you at least have to have the interface of the app. If your app is more complex than an app that only include the interface, the app itself, you will have to include a backend developer. And also, if the app grows bigger, you have to have like big data developer or data mining developers, testing group, data analysis team, for etc. So this is the structure of the tech team. And if you are running a company, so you can still you can still considering recruit the operator team or customer service team or BD group, user research. So there is a lot of function of like that you can consider to include those people into your app. But I think for our current situation, ourselves have to take up those roles as like customer service and user research. So we have to do that all to help our app grow to a real app that real people are using it. So for the next slide, please. So I have listed some questions that have come into my mind that you have to consider when you start to develop your app. So the first one, I think it's very similar to what Anna have already discussed. Like you have to identify your user, who is going to use your app, and how are they're going to use them, what kind of benefits your app are going to bring to your user. And one most important question is where you find your app after you launch them. You're gonna purchase some advertisements, or you're gonna launch your website, or you're gonna introduce them through WhatsApp group or Facebook group, etc. There is a lot of ways, and I think it's very important that we can think about this question when we start the planning. And there are other questions that we can go through, but I think those are very detailed questions you should consider. And I think when you have go through those questions, you can let's say at least you have made a step forward on your app design. Thank you. I think this is the end of my part. Thank you.
Prachi, over to you.
Yes. Okay, great. Thank you so much, Wen and Anna. It was such a delight listening to you both, and I learned so much from your presentations. So packed with value and information. You really get so much in just a few minutes. So thank you so much for that. I wish I had listened to your presentations when I was starting out with Cool the Globe, in fact. What I'm going to be talking about today, I'll just in a minute or two just briefly talk about the app that we built, Cool the Globe. And then I'm going to be talking about the 3 phases of app development that we went to, and 3 key learnings and approaches that really helped us during those phases. Now, before starting, I should give a heads up that I'm not a technical person. I'm not an app developer, or I don't have any background or expertise in building an app. So Wen and Anna beautifully gave out the nitty-gritties of what technical knowledge you need to actually build an app. I didn't have any background in that, but I do think, nevertheless, that I may have something of value to share here, because all we had was an idea to build a platform, and we did not have any expertise or did not have any idea on how we could actually go about building an app. By listening to it, I'm hoping you'd get sort of a top of the line idea of what it takes to go about self-learning and creating an app or a platform. So a big part of my interaction is going to be about self-learning and how we went about actually acquiring all the skills that are needed to build a platform. I'm essentially a founder of an app called Cool the Globe. What Cool the Globe does is that it helps users like you and I reduce our own greenhouse gas emissions and our carbon footprint to a target. It shows citizens simple day-to-day climate actions that they can take in their life and the emissions they are avoiding with each action. And I think perhaps the most important part is that, a lot of people think that one individual can't do a lot. And we wanted to, through this platform, show the power of collective actions being taken out by citizens from corners of the world coming together. And so we have a global meter on the homepage of the app, which shows the collective emissions avoided by everybody on the platform. So today we have users from about 100 countries. And over the last years, all of these users have collectively avoided 1 million kg of CO2 emissions. So that's essentially the app that we built. Now, talking about the stages of development, the first thing
thing that I would like to talk about, the first phase that anybody would need is to build domain expertise. Even before you start thinking about the app, think about the core idea of what you're working in, and what is it that your platform is all about. For me, it was about bringing climate action to the common man, making climate action easy and accessible. So even before we started thinking about the app, the first phase was in just building that domain expertise. We did a lot of research into Energy Star programs from around the world, per capita greenhouse gas emissions of all countries. Where we scoured through IPCC, EDGAR, World Bank, IEA, these organizations, and every single report that they had, emission factors of different appliances, and just even talking to ordinary people on what climate actions could be easy for them to take. So even before we start thinking about a platform, if it comes from a strong foundation, then that's going to be worthwhile. So the app is at the end of the day a platform. So as long as we have strong domain expertise, then that platform is going to be successful. So I would strongly urge anybody who wants to build a platform to first focus on becoming an expert in the domain at which the app is working in. So once we have that, then the second phase is about storyboarding and what the structure of the app is, what it's going to look like. For that, so at the time that we started working on it, there were quite a few storyboarding platforms and softwares that were available for us to do that. But they all seemed a little too intimidating for me. It was too much work to learn them, and it just seemed like too intimidating. So we just started with a simple pen and paper, and we just scourge in different sorts of screens that we want in the app. Storyboarding is essentially a journey that the user will go through. So I had this huge cardboard put up in my room, and we just I had tons and tons of empty mobile screens drawn on that cardboard, and I just wake up and start drawing on it. And that's essentially what simple storyboarding looked like to me. Storyboarding is essentially visualizing the journey that a user will have on your platform. So in the first phase, you build expertise on the domain. In this phase, you build expertise on what your user wants. How can you make your platform the easiest for people to use? What is the psyche of the user? So in this phase, we did a lot of research on nudge theories and behavioral theories, which would help people focus a lot on climate action, or which would help them take up climate actions. So that was the part about storyboarding. And then we came to what it would look like. So the UX and the UI of the app. So for that, in the backend development of the app was done by my father. For the front-end development, I learned Java coding, and I learned how to do UX UI. So in this phase, a big learning that I had was that we hear a lot about the importance of being unique, but in the phase of learning and when you're trying to do something new, I think imitation is very often underrated. For the longest time, I would just, look at tons and tons of other apps, and I would literally imitate the screens that they are doing, not copy them, but imitate. You look at how they have made the same design sleek. What are the best UX and UI practices? What other platforms are doing? I think a good formula to success is find the best of what others have done, imitate their framework and structure, and bring your own unique twist to it. So I think when you're trying to learn something that you're not an expert at, imitation is truly a very big gift. So that is one big learning and approach that I had in this field. I found out platforms like Dribble, where other app developers and UX UI designers would put up their work. And I really learned a lot from the work that they had done. So then the third phase that we actually get to is the actual app development and the coding. And a large part of this was done by my father, but he also did not have any background in this. So we learned coding that was needed on our own. And in this, what was really useful was to find out who is the god in this field that you're trying to learn. So in coding, for example, we read this book by Joshua Block, who is perhaps the top person, who really, he was the best person to go to in that field. He had this book called Effective Java. And through that book, we learned a lot about coding. There was also a lot of people on Stack Overflow that we would interact with. And even there, we would have to figure out, who is the person who really knows their stuff. And then we would go and ask doubts to them. So a big mistake that we did in this journey is that we first started developing on Android. And then, because at the time, there were no platforms like Flutter, which would allow us to code simultaneously for iOS and Android. But then later on, we switched to Flutter, and now the iOS app is on Flutter. We used a lot of mix of different languages. So, for front end, we did Java, MATLAB, Dart. So a lot of mix and match of different sort of languages like these. A big thing in coding also is that for a lot of things that you want to do in your app or your platform, other people would have done it before you. So very simple things like a calculator. There are tons of apps and platforms that have already done a calculator. So you'd get a lot of help on that front. But there would be some features and some things that are very unique to your platform. So for us, a key challenge was in building that global meter, because there was some complexity involved in that. We'd have to synchronize the user data, display it, take it to an external remote database, and then showcase it in real time in the app. So there was some complexity involved in that. So that took a long time. Things that are very unique to your platform are going to take the longest time. And things that other people have done before, it's best to approach them and take help from the people who really know that stuff. So that's one key learning. And in this also, there was another big learning, which was there's a person called Richie C. He's a language creator. And he had talked about at the time, which was very impactful. So we first spent a lot of time in just learning coding. So many months in our home, everybody was disrupted. We'd learn coding from day to night. And then we, came across this quote by Richie, and he had talked about how the only way to learn is to start. We were just so focused on learning it very well first that we had not actually started developing yet. And so I think our biggest learnings on how to build an app actually happened when we started building an app. You start building it, and whenever you come across a doubt, you go on these platforms like Stack Overflow, you ask people. There are big communities of people to help you out in this day and age. But don't stop because you don't know things yet. Start doing it, and as and when you come across challenges, then learn how to go to the next step. So I think in programming and app development, it's very important to just get into it as soon as possible. So this was essentially the journey that we had. Anna also said, you have two options. You can do it yourself, or you can also, find a co-founder, hire developers, hire technical experts who would build your platform for you. In both cases, I think nevertheless, it's also important for you to not know everything, but know a little bit of everything. Not know everything about everything, but know a little bit of everything. So you have people who have expert knowledge in different domains of building a platform, but you have a vague background of what's happening. You're not clueless in the whole process. So I think that's also very important. So that's essentially the experience that we had. Because we were not experts, it also took us a long time to build the app than it would have, to somebody who's a developer. But then, it takes you a long time to do anything for the first time. But when you're doing it for the second time, then you get it like this. So that was essentially my experience of being a noob in app development and still somehow wiggling my way out of this. And so I only hope that, listening to this, if somebody wants to build a platform, an app, and doesn't know any idea of how it's done, my advice would be to not get intimidated. Just start it. We have in our day and age, so like my father used to say, when he was young like me, there were minimal resources for anybody to do anything. They would have to go to the library, find thick books, find sections on how to do stuff. Today we just have to do a simple Google search. We have to go on LinkedIn and find experts who are working in this domain. We can go in our friend community and we can find a developer who knows how to do it. So we have a lot of resources in our times. So not knowing the technical knowledge on how to build the app should be the last reason for somebody to not build an app. So I hope that anybody who has a great idea can start working on it. And essentially, this was my experience of building Cool the Globe.
Thank you so much, Prachi. Anna, over to you.
Thank you so much, Drishya. If you could share from slide 10, please. Well, while Drishya starts, okay, now the presentation is on. Well, first, before I start the second part of my presentation, I just want to say that I've really enjoyed what Prachi and Wen have said. Even if the three of us are involved in app related things, it's so important to learn from different experiences and gain new ideas from people who are doing similar things to you, but that they took different pathways, and I think they can always complement each other, right? So thank you both. I really learned a lot from everything you've said. And now to go into the topic, now I would like to talk for a few minutes about launching your app. And regarding launching your app, I divided it into three different sections. We will talk first about testing, then about the preparation, and then we will talk about the actual launch event. So regarding testing, we need to finalize testing with small groups. As I was saying before, we need to make sure that the users we choose in these different small groups are very, they have a great variety, right? So people from different states, or if you're going to launch an international platform, people from different countries. And something that's very important is to get insights from the testing, because the idea from the testing is to really use it to make the app better, right? So what we have done is create different surveys before and after they use the app, talk to the different users. Regarding the preparation, we will talk about preparing your app for the stores, thinking about putting together the required informations and preparing the pictures you need to upload. And finally, we will talk about the launch event, how to prepare it, preparing the marketing campaign, and inviting the media and your target users. So if we go to the next slide, we will go into the specifics of testing. So as I was saying, you have to make sure that you use different surveys where the users can add both their comments and their concerns. And it's important to address these concerns that they share, unless it's something that really throws off what you're doing and doesn't really go well with what you're trying to achieve. It's really important to think about why the user is making this comment and how you can fix it to make the user journey simpler and easier for them. You also need to choose a varied group to get different comments and experiences. You need to make sure that the users know that any comments they make will be of great help. This will help them become more sincere and more transparent, because something that's very common is that sometimes the users just want to say the good things and they don't want to make to say it this way, bad comments that will really help you improve. So it's important to create the trust with your testing group. If we go to the next slide, we will talk about preparation. So something that is very important is that sometimes we have finished developing the app and we forget to start all the preparations needed to upload it to both the Apple and Android store, which can take a few weeks. So we need to make sure we keep enough time to start the process for both the Apple and the Android campaigns. And keep in mind that Apple requests something called DUNS number, which may take a couple of weeks to get. So make sure a couple of weeks before launching, you're already looking into that. You also need to keep in mind that there's a payment you need to make yearly, both to the Apple and to the Android store. And you must prepare the different contents that you will put in your app page within the App Store, right? So thinking about keywords, descriptions, names, and contact information will be really helpful. And make sure you use specific keywords and the specific wording that will help your app be easier to find, right? So for example, add a if for example for my app, which focuses on climate action and reducing the water footprint, we can look for keywords like climate action or water footprint, things like this, right? So it's easier for people to get to it. And something that's very important is when you're going to download an app, you can see that there's different like screenshots or screens of how the app will look like. Something important is creating these different pictures with a lot of creativity, including key messages and everything, so people know what the app is about and they're more interested in downloading it, right? So other than just uploading the screenshots, you can create different designs that include the screenshot but also have additional messages. And finally, when we talk about the launch event, if we go to the next slide, we need to decide, first of all, on the budget we will keep for the launch event. This will be very helpful as we keep on planning to make sure that we stay within budget and we know the scope of the event we will have, right? Something that's very important, especially now that we have the COVID situation going on, is to decide whether you want your event to take place virtually or physically. There are a lot of benefits to either type of event, but it's important to decide from the beginning. Something that has been very helpful for me is creating a Gantt chart or a calendar so that we can make sure that we stay on top of the planning, right? So that we know that 3 weeks before the event, we need to be contacting these people, and 2 weeks before the event, we need to be doing these other things. So it's a great way to really keep up with what you need to do week by week. Also, we need to keep in mind that you may need to contact media, influencers, or experts, which may have a crowded schedule. So it's better to do it with more time. Also, you need to decide whether you would like to gift something to the participants. For example, thank you for coming gift or an intro kit or something like that, and make sure this is considered within your budget. And something that's also very important is to make sure that this kit is aligned with your values and the significance of the technology you're using, right? So for example, if we're talking about climate action, in the welcome kit, I will not put a piece of meat, right? I would maybe put some package-free things and maybe a book about climate action and maybe, I don't know, some fruit, things like this, right? And something that's also very important is to create a simultaneous campaign on social media, because even if you have an in-person or a virtual event, not everyone will be able to join. So it's important to keep the momentum going through social media and make sure you know your audience well enough to choose the best channels to access your target audience. And finally, something that's also very important is creating a landing page where people can access to learn about what your app is about before downloading it, right? So for example, I hear about the color book and I'm like, oh, what is this about? So I Google it first to know if it's an app that I would like to download on my phone, right? So first I would look into it, and having a landing page is a great way to explain to your user the objectives and the values of the app you're creating. And that way they can decide whether they want to download it or not. And they have the direct link for the download right there on the landing page. So these are some things you need to consider once you go into your launch event. And that's all on my side. Thank you so much for the opportunity of talking to you about this. And if you have any questions, you can put them in the chat and I'll be very happy to answer them.
Thank you, Anna. Thank you so much. I think Prachi, Anna, and Wayne, your presentations were amazing. There was so much insight into if we want to work on something like that, what can motivate us, whatever limitations or whatever challenges we are facing, how to overcome that, and all the technicality that is involved in actually starting to work on it and while you're working on it. And a lot of market research, which is, I think, very, very important for any project, and specifically for app. There were multiple modes that you discussed via which you can actually think of promoting your application separately to what social media activities you are doing. So thank you so much for pointing out each category, I mean, each point under each category so well and presenting it with your own experiences. Um, Thank you, Prachi. Thank you, Anna, and thank you, Wayne, who has actually left us because she was supposed to join a meeting. But I would like to ask if anyone has any questions. I know it's a lot to process, but everyone can chime in when they have a question. So, Ivan and Kevin, please go ahead.
Thank you so much. Uh, well, first of all, a comment about what Prachi said, that you should know a little bit about everything. I think that's like that works a lot for the app, but also like for the companies or the projects that we are doing. Let's say, in my case, I know a little bit about everything in resilience, right? But David, he's like the main person, well, the person in charge, the director of the area of development. So yeah, that totally works. And well, my question is, what for all of you, what do you do to protect the personal data of the people that has your apps? Thank you.
Thank you, Ivan. That's a great question. And if I may answer really quickly, what I wanted to say is that there are many different programs that you can add to your app in order to make sure the safety of your user is assured, right? So, for example, there's one. Let me remember the name. I have it written down. Let me find the name and I'll give it to you. But basically, what it does is that you pay a membership and it secures the information of your users. Many banks or different things use this app, and it depends on the number of users and on the level of protection you want to give your users. And something important to consider is that the level of protection depends on the sensible data that you're taking from the users, right? Another important thing is to make sure that the users are well aware of where to find both the terms and conditions and the privacy policy, so that they're aware of what information you have of them and how you will be using it.
Thank you so much.
Well, I want to say that, well, first of all, it's a great presentation from the three of you. I'm inspired to make an app, although I don't know anything. But now I learn a little bit more, so it's really great. My question will be, if, like Prachi said, what's important is to do things even though you don't know. So you learn in the process. But sometimes you face something that probably could be, if you will have known something before, probably would have made your path easier. And have you come up with some of these challenges, and how you have come up with the solution?
Thanks, Kevin. Prachi, I don't know if you want to take this question. If not, I can take it. I have no problem. Okay, I'll just go ahead. So Kevin, what you're asking is what I learned through the process that it would have been better if I knew from the beginning, right?
Yes, because you faced a big challenge, but
yes.
If you have known better, probably you have faced it another way.
Yeah, that's a great question, because, and I feel this happens to everyone, because there's so many different ways to learn about app development and about different things. So it's important to keep in mind that you will be learning, right? And there will be things that you will learn in the process, and you will say, oh, I wish I knew this before, but it's part of the process, right? So you shouldn't get frustrated. On my side specifically, something that I wish I learned before is to create a simpler app and a simpler product and make it better as you go. Because sometimes you think you know exactly what the user is going to want, but in the end, and you create this very robust platform, right? And once you launch it, you realize that they only wanted a fraction of that, so that they're only using a section of it. So you think, oh, I should have launched a smaller version first and built from there, depending on what the users want, right? So if I were to create a different app starting today, I would definitely aim for a smaller beta version, and that's faster and easier to launch, to make sure the testing process is part of the project from the very beginning, and it's not left all the way to the end.
Perfect. Thank you very much. Great answer. So testing and doing and side by side it's really important. Thank you.
Mida, please go ahead. Mida, please go ahead.
Thank you so much, Drishya. Okay, I'm just going to do something small and then I'll come and ask the question. Please, like, I have to open the door for someone. I'm sorry.
I don't know if I heard something else. She mentioned that she'll be back in a minute, right?
Yeah, she said she'd be back in a minute. I don't know while Mira comes back if anyone else wants to ask something else.
Oh, I'm back.
Oh, she's back.
Okay, hello everyone. I'm really so sorry. My question, first of all, I would like to thank for having your your brilliant presentations. I really do like the innovation you all are having, and it's actually very inspiring for now most of us here who have really not ventured into that lane. But then I wanted to ask a question for you who have already gone into the process of making the apps. While you are sitting down and making, or you decide to come up with an idea of making an app on something, you know how most of you have ventured into climate related issues, and in most cases while you sit down and you're trying to put up something, the idea is fixed and it's okay. In most cases you really do not have to think so much on the aspect of public analysis or something like that. Now asking on something to do with more of like health, in this case, like for example, if someone was to make an app or more of like creating awareness on something, or I just happened to think about it while we're doing this, because currently I'm like struggling with coming down to a final level on something that I'm going to engage the public in. But then I was now trying to imagine, like, if you are to do it in terms of now making an app or something like that, it's something like to do with public health and climate change as well, because I'm more of like pushing for reusables, in this case, reusable sanitary towels and how do they call them? Diapers, as a way of addressing the issues of menstrual health management, girl child education and all. So if one was to create an app, more of like creating awareness or sharing stories of most of these people, you know, in most cases, people tend to question, like communities that don't have water won't be able to use most of these reusables and all. So while you are sitting down and creating the app, you sit down and focus on like your personal view, like, okay, I've seen this and I feel like this and this, and like you add up things and then maybe focus on that lane, or you have to go and ask people outside as well from other communities, like get the other perspectives of whatever you're trying to settle down and do. So you try to create sustainability for both sides, or you have to zero down to one aspect, or how can I say, at least make sure that you have both pictures of the story in whatever you're trying to develop or bring up. Yeah, something like that. I've tried to summarize it. It was on short notice, but I really tried to summarize it in a manner that I hope you understand.
No, yes, that was a great question, and I completely understood what you mean, because it's a question we get pretty often, right? So if you're trying to create a global solution, sometimes the use of technology isn't inclusive because there are many people in rural areas that don't have access to the technologies, right? So that's why in the beginning of my presentation, remember how I first spoke of spotting the problem and finding the current solutions and how these solutions can be improved. It's important to think about that before, so you can decide whether an app is the best solution for the problem you're trying to solve, especially where you're trying to solve it, right? So, and something that's very important is, for example, you were talking about storytelling. So maybe there are some things that you can do before creating an app to make sure first if an app would be useful, right? So maybe start with a blog with the stories. And if there's enough people using the blog and enough people interested in it, you can go ahead and then create an app. And something that's very important is to make sure you're using the correct technologies or the correct assets to access your target audience. For example, in the color book specifically, we're trying to access those who have the biggest carbon footprints. And those with the biggest carbon footprints are those who use the most technology, right? So that's why we decided and we went with creating an app. For example, if we wanted to impact local communities in the mountains in the middle of the rural areas, then maybe using an application wouldn't be the best way to create an impact. So it's always important to think about the context of the solution you're trying to implement.
Thank you so much, Anne.
Thank you, Meda, and thank you, Anna, Prachi, and Wayne for this amazing session. Now I would like to invite David Martinez, um, who is a graduate with a degree in biology from National Autonomous University of Mexico, conducting studies in biomedical research institute of the same university on the cell fusion promoted by the human immunodeficiency virus type 1. He was accepted in the direct doctorate program continuing on the line of immunology and infectious disease. 1 year before graduating with honors, he began collaborating with researchers from the Institute of Physics and Center of Complexity Science at the same university on projects in biomathematics, complex systems, mathematical modeling of cellular functions. He's currently doing his postdoctoral stay focusing on complex system, data science, machine learning in the Department of Quantum Physics and Photonics of the Physics Institute of his alma mater, developing innovative mathematical methodologies and carrying out research, teaching, and collaboration with multidisciplinary groups. Dr. Martinez has several international publication and academic awards. Um, Welcome, David. I'm so inspired after reading your bio because I come from a microbiology background who entered into public health, and I have a lot of inclination towards data analysis because that's what the public health is supposed to do. So I really look forward to learning a lot from you today.
Thank you. That's awesome. And I hope that my presentation will be useful to you and, of course, to everyone here. Could I get permission to share my screen?
I think you already have it, David.
We can see your screen now.
Okay, thank you. So my presentation is focused today. Can you hear me?
We can hear you.
Okay.
Yes, perfect.
Is focused on talking to you about how complexity sciences can help us to solve problems better. And as you already know, I work with complex systems in a physics institute, and I wanted to give you something useful that you can apply to everything, even if you work in app developing or in environmental issues. I wanted to give you an alternative view to understand better the system that you're working with and how to approach it to solve problems. So that's the objective of this presentation. Okay. The problem that I present today is that nowadays we use almost in everything, we use a reductionist view and reductionism in approaches to solve the problems. So this perspective is widely used, and it has been used for a long time in science, from the times of Newton, where the scientists and philosophers thought that we could explain everything if we understood the basic laws of physics and math that govern the elemental particle laws. So in that perspective, we could understand every phenomenon, even the consciousness, by just understanding a few laws. And this thinking, this perspective has been rooted, it's very rooted and ingrained in our thinking today. And these photos show little examples of in pop culture and in documentaries of physics about this idea. No? And well, what I present today, my message today, is that we need to change a little bit this perspective if we want to understand the big picture of the problems that we are facing today. Because reductionism, although it was very useful in the past, and it's very useful today, yet it is more adequate to solve little problems. But if we want to approach real global issues like global warming, social injustice, and other stuff, we should use other perspective that I propose today. So the problem with reductionism is that it assumes some points. One of them is that reality lies only in the realm of physics. That means matter and energy. That the universe is predictable if we know the laws that are behind it. Everything can be described by the aggregation of the elementary particles. That means matter. And that there must be a unified theory of everything. And if you already, maybe, well, surely you saw some documentary about physics or some commentary about physicists, that they are really obsessed to find a global general unifying theory of everything to explain how the universe works and how reality works itself. So the scientists, the reductionist scientists, think that even events, a phenomenon like consciousness, can be described only by math. And I say that reductionism although useful in the past, is now outdated. First of all, a grand unified theory of everything is hopeless because physicists ignore some things, some important things. The most important one of them is that in complex systems, there exist interactions, and interactions are very important at different scales because the interactions between the elements that conform a system generate novel data on the run. And this novel data is not considered by the fundamental laws of physics. Complex systems also present adaptation, and the interaction data also generates a new context and perspective. And this, in consequence, brings meaning to the complex systems. And as you must be imagining now, well, most of the reductionism scientists ignore completely things like that, like meaning. In fact, we have heard a lot of times that in the reductionism point of view, that life really doesn't have a meaning. It's just the result of probability. And well, I have these alternative views, and I hope that they will be useful to you. So in the complex system approach, we, as I already mentioned it, the most important thing is that interactions generate novel information on the run. That means that we think that a phenomenon is not only the sum of the parts that compose it, but there's also the interactions between those elements. And the interactions generate new information that we cannot predict from a set of initial conditions. And the only way to see this new information is to run the model or to see the system running in time. That's the only way. And that is called computational, non-computational reduction. And here is an example. This is the game of life created by John Conway. This is a computational game which has a set of rules. The rules are very simple. We have a grid in which a cell can become alive or dead, depending on 4 simple rules. If a cell is living and has no neighbors, it will die. If a cell has more than 3 neighbors, the cell will die. And if the cell has 2 or 3 neighbors, the cell will keep on living. Or if an empty cell has 3 neighbors, it will become alive. Those are the 4 simple rules of this little game. And the dynamics that it produces are very interesting. We have an example here in which with the set of initial conditions, we can have some dynamical behaviors of the system. And well, the system eventually reaches equilibrium and it becomes stable. But what I want to show you is that 4 simple rules, depending on the set of initial conditions, can produce very interesting behaviors and systems. These are few examples of what can we achieve with the game of life. And with these 4 rules, we can achieve some really complicated and interesting systems. We can get like colonies of living like beings. We can get spatial ships. We can get something like little universe. And this shows us that even if we didn't implicitly program these behaviors, these are characteristics that emerge from a set of simple conditions. And this is a great example to illustrate how interactions generate this data that I was talking about. And it is impossible for us with the set of initial conditions to predict that this will happen, but it happens. And it's really interesting. So this is just an example. So yeah, that was just to prove how interactions generate new data. Okay, now reductionism versus a complex systems view. This is what I want you to keep and to go home with. Okay, reductionism assumes that there is a materialism. That means everything lies in the realm of matter and energy. Reductionism says that the universe then is predictable. And this gives us a Platonism view of things. That means that there's only one truth that we should get from the unifying theory that we don't have yet, and I think that we will never get. But that's the goal of a reductionism view. And of course, if we have a set of equations that describe the universe, then that gets us to a nihilism view of existence. Because as I told you, well, existence has no meaning. And it's just exists because of probability. In the complex systems view, we have alternatives to all of these points of view. Instead of materialism, we have informism, which is another perspective to view everything in the realm of information instead of just matter and energy. We have adaptability, because we know now that complex systems are not totally predictable. The systems can adapt and can evolve. So a problem that maybe we know now can change. And in some time, we won't know how it's working. Instead of Platonism, we have a view of contextuality. And instead of a nihilism view of existence, we think that the interactions generate meaning in the phenomena. So what about informism? Okay, instead of thinking of existence in the realm just of energy and matter, we think that energy and matter are just one kind of information. And this is because in our practical life, we not only use or exchange goods in terms of matter, and we give them value. We give value to even non-materialistic things like services, software, even money. We can argue what's the value of money. What gives it is its value. We trade in shares. We give value to art. And the value that we give to those things is not based on the number of atoms that they contain. So we give art a value based on what? Well, the value of all those things, non-material things, is agreed upon interactions between people. We decide what is the value of software, what is the value of even modern art like NFTs. I give an example here, the cryptocurrency, and we even value more meaningful things like helping others, helping the planet. We try to help animal species. So we give value to non-materialistic things. That's the point of informism. And the new value that we give to those things, it's generated upon interaction. So this is one way that interaction generates new data. Non-predictability. We think that complex systems are not predictable at all. This was an idea that came from reductionism. In fact, here is an image of the Laplace demon. Laplace thought that something similar that I already told you about reductionism, that if we know the laws that govern the universe and a set of initial conditions, we will be able to predict everything through time. And we think that although it's an interesting idea, and it can be applied to at some level, at some scales, in some experiments, complex systems are not really predictable. Again, because the data, new data is generated because of the interactions, and we cannot predict those interactions. So that's what we call computational irreducibility. So even if it's an interesting idea, the Laplace demon is not really useful today in complex systems. Non-Platonism, that means that there's not only one truth for the universe. In the complex systems perspective, we prefer to use contextuality. That means that there can be infinite truths depending on the context we are using. And here I have two examples, two contrasting examples. The Platonism says that philosophy and science search for the one truth of the universe. And in the complex systems view, we have many examples how something can change, how the truth of some phenomenon can change depending of the context. Here we have a little example how if we see a 3D sphere going through a wall, well, in 3D we can see that there's a sphere and there's going from one side to the other of the wall. But if we live in a 2D, two-dimensional world, what we can see is totally different. We see there's a circle, there's a little circle that will become bigger and then become small again. So the truth changes depending on the context that we are. Other examples are, for example, 1 + 1, well, it's 2, but that depends on the number base we are using. If we change to the decimal, that result will change. So for complex systems view, context is really important. And as there are potentially infinite context for the phenomenon that we're looking at, there can be potentially infinite truths. So all of these that I mentioned generate a new meanings for the phenomenon. So instead of having a nihilism view, that means that existence has no real meaning, we think that the interactions between the elements in a system generate new meanings, and that there is potential infinite meanings for every phenomenon. And this view is interesting because it brings a new scientific spirituality that it maybe sound weird because many reductionist scientists deny these kind of meanings. But I think that finding meaning in some phenomenon can be really enriching. So, okay, that was a little of philosophy, but let's see how these ideas can help us to analyze systems and find solutions in a better way. So in complex systems, sciences, how do we analyze complex systems? Well, we have a system and we don't understand how the system works in the big picture. But what we can see are two things. We can analyze the data that the system generates. That means its dynamics. Or we can start to try to understand the interactions between the elements that compose it. So here we have the two approaches. And in fact, the first approach, focusing in the data generated by the system, belongs to the realm of data science. Data science, this is what it does. It collects data from a system, whatever it is. It can be an economic system, a marketing system, etc. And collect the data, organize it, process it, and from the data, find algorithms that allows us to predict in a very limited way how the system will behave. We can also use data science not only to try to predict the system, the system's behavior, but also we can use the data to try to understand how the system works. In the other way, we have a different approach that is to start trying to understand the system, how the elements are related between them, and then make a model of all the system and run it and see how its dynamics work, and if in reality the dynamics are adjusting to the data that we see in real life. So we have those two approaches. Which one is better? Well, it depends. I like to make this analogy, the analogy of evaluating the aptitude and abilities of child in schools. It is very common that we go in childhood through a series of exams and evaluations to know what we are good at and which one is the career that we should pursue based on these aptitudes and skills that we have. So is it better to evaluate a child with a written exam? With the exam, we will know if the child is better at sciences, at philosophy, at verbal communication, at art. The exam will give us all the data. But the data alone, is it sufficient? Well, there is another approach. We have counselors, and the counselors talk to us, asks us questions, asks us what we want, what we like, what do we expect from life. And from those questions, they can also generate a picture of what is better for us. So which one is better? Well, I think that the two approaches in combination are better than just one, because one is focused on the data resulting from the exam, and the other one is based on the feelings, on the way of thinking of the child. But if we use both, we can have a better and more complete big picture. And then the child can have more information about what's the best career choice to pursue. So it's a good analogy for the analysis of complex systems. Each approach by itself is limited because one is focused on the data that results from the system, and the other one is more focused on just the interactions. So if we want to understand the big picture of our systems, we should use both approaches. We should focus, of course, on the results, on the practical results, the data, but we also should focus a little bit to understand how the system works by itself. So this is what I'm proposing is a more is the complex system view, and I wanted to share this with you because data science is something that is very used worldwide in corporations, in organizations. They all have data scientists, but data scientists, although useful, are making limited decisions and analysis because they are focused only in the data. So here I propose a more integral view in which we also focus on understanding the interactions. So this will allow us to make better decisions, being for an organization, for fighting environmental issues or social issues, etc. Because everything in the end is related in a web of interactions. So here's the example. We have different environmental issues. We have deforestation, pollution, global warming, and we have also social issues, hunger, war, social injustice. In fact, these are all related in a network. We are facing a very complex system because we want to face the world's issues. And I think that this perspective that I am talking is a better perspective to find the solutions to those issues. And what am I saying this? Because I see that in this world, there are also a lot of reductionist examples of solutions that we hear in the media all the time. So if you want to fight environmental issues, you should use your common senses. Well, not really, because this is a complex system. And complex systems are not that obvious. So we cannot understand them just using our common senses. We hear a lot, leave fossil fuels in the ground. Well, again, not really, because if we switch to full alternative energy resources, we can generate even a wider carbon footprint. So it's not that simple. Stop eating meat and switch to a vegan diet. Well, it depends. As I already said, the context is very important. So not everyone, not every country can do that. So these reductionist solutions that we hear all the time in the media are not enough to find solutions to the environmental problems. Environment is a really complex system. So we should start approaching it from the perspective of complex systems. Here are some examples. For example, water, it's being is start to be seen as a complex system. In fact, the theory is that all the water in the world is connected through a complex network of subterranean and surface water bodies. So now scientists are looking at these networks to be able to predict how the water will behave. Maybe some lakes will dry, but the water will go to other places. So if we understand these water networks, maybe we can predict how the water will behave and how we can exploit it in a responsible way. Other example is that global warming. In fact, climate has been seen as a complex system for a long time. Lorentz equations demonstrated. In fact, the climate is a very complex system and really unpredictable. And this is not only because it's a chaotic system. That means that it's very sensitive to the initial conditions, but also we have seen that, in fact, the interactions between the elements of the climate generate this new data that I was talking about. That's why, in combination with some chaotic behaviors, that's why climate is too difficult to predict. But nowadays, it's treated like a complex system more and more, so we can understand better what's causing the climate change. Of course, we humans are accelerating it. I think that there's no denying of it, but there are also other elements that are in play. So it's being treated more like a complex system in more scientific, serious studies. Also, another example is this city designing, urban designing, how cities become what they are. And that's a complex system that involves people, involves social activities, economy, even geography is involved. So urban designing, urban planning, it's being approached as a complex system now. So those were some examples. I thank you for listening and for the invitation. And I hope that this alternative approach and view is helpful to you, and maybe to find better solutions to all the issues that we are facing today. Thank you.
Thank you so much, David, for your presentation. I would like to ask the audience if anyone has any question for David. Please go ahead, Kevin.
I don't have a question, just like it's more like a comment. Like, so you're suggesting, sorry for the noise, but so you're just suggesting that we use that tool that is being used right now, well, all the available tools that is being used right now, and that by companies that are driving harm on the environment, but now using it to actually make a better world. So that's why I mean it's more like comment, like a question. So I think that's a brilliant idea. So it's like if it's already available for everyone and someone is using it, but it's not for the right purpose, why not should we also use it and drive a really important impact, environmental and social impact? Great presentation. Thank you very much.
Thank you. Yes, in fact, that's a very interesting point. These tools can be, in fact, used wrongly and could be, how can I say it? In the wrong hands, they can be harmful. In fact, they have been used by the military. They have been used by some non-good intentioned companies to make use of our data. I won't talk about specific cases, but yeah, these are powerful tools, and if we use them to try to make a good change, a positive change for the planet or for societies, of course they will bring positive solutions. So yeah, thank you. I think it's a positive message.
Thank you very much.
Thank you so much for the presentation. I also want to ask, well, this is actually a paradigm shift for anyone who is, I don't know, some people can have different ideas, right? So some people can agree with that, some people can think of other way, but for those who are interested, do you have like any ratings or something that we can check so that we can learn more about it and start implementing it? Because one thing is to have it like theoretically or understanding the idea, but maybe putting it into practice in our projects may need some a little bit of more basic understanding. I'm not sure if I'm being clear. So any lecture, like basic lecture about this would be really appreciated, I think, for everyone here.
Sure. I think that an appropriate lecture would be any article from Carlos Gershenson. He is, in fact, a complex system scientist from here, Mexico. He works in the same university as I. And I think that his articles from 2011 are very good, and they are available online. So that would be a very good basic lecture. And I also wanted to say that, yes, you're right. In fact, this is somehow a novel perspective, but it is an alternative. And I want to repeat, reductionism is not bad. It is not something that we should just throw in the trash. It is very useful, and at small scales, it is even more useful than complex systems perspective. It allows us to do more experimentation, and it helps us to find solutions to small and simple problems. But the problem with that is that we want nowadays to approach big problems with a reductionism view, and I think that is what we need to change. Maybe. So we should use the two views, the two alternatives. We should use the two approaches depending on the scale that we are working with.
Maybe an analogy that I'm thinking right now is like the quantum physics and the classic physics, right? So one laws apply to really small things and the other to our world, and neither of them are wrong, so they just work differently and they coexist and exactly. Are true at the same time.
Yes, exactly. You cannot use quantum physics at large scales, but in fact, quantum physics is really useful to the subatomic particle universe. So yes, that's a very good example of this view.
Okay, well, thank you so much. And if there's no further questions, I'm going to wait for someone from the audience. Otherwise,
I think Vera has a question.
okay, please go ahead. You're muted, Vera.
So yeah, hello. It was such a great experience here to learn a lot from that insightful discussion. Yes, I just like to ask a question. So this is addressed to all the speaker. If you wanted to. So here it is. As we observe that we are now in the world where people rely more on terms of technology. So I just like to ask if, for instance, do you have something like you are afraid for in the future using the technology as it becomes like the development of the technology? So that's it.
I don't know if you want to answer the question, David.
In fact, I didn't heard the the question. I think there's some interference. Could you repeat it for me?
Am I audible lately? Can you hear
Yes.
my voice?
Yes. If you could repeat the question, please.
So my question is just, do you have something that you are afraid for in the future? As we observe, we are now in the more on relying on technology. Yeah, like the machine learning development. That is it. Thank you.
You're muted, David.
Okay, now that's a very good question. Yes, in fact, I have a fear that we will stop using our criteria to understand the problems that we're facing. Because if we rely too much on the algorithms, on the machine learning, and on the artificial intelligence, people tend to stop using their own criteria. And I think that we should never stop using it. I think that we need to be always self-critical and think about the results that these algorithms are giving to us. I think that's very important. Always use your own criteria.
Well, thank you so much. And with this, we finish today's session, unless there's someone else who wants to ask. And if that's not the case, thank you so much for being here. Thank you so much, David, and all of the participants for your invaluable sessions and presentations of today. And well, we'll see you in the next Conclave session. Take care.
Thank you, David.
Thank you.
Thank you, Anna. Thank you, Vera, Meda, Prachi, Ivan, Kevin. Thank you, all of you, for joining us today and for this valuable presentation. And all the learnings we had today, and also to all the participants who asked questions, because they really provoked the thought to how can we better understand and implement all that information that was shared today. So thank you so much, David, and Ivan and Kevin. Thank you.
Thank you so much.
Thank you.